This afternoon we're going to talk about architecting Horizon 7 and Horizon apps. My name is Graham Gordon. I'm a senior staff architect with the EC business with VMware. One of my roles is to help with reference architectures, and we're going to reference two reference architectures today in my section, and another one with Frank. Frank, do you want to introduce yourself? Nope. Please.
Hey guys, I'm Frank Anderson. I'm an end-user computing solutions architect, or Graham, in the tech marketing group here at VMware. It's my pleasure to present with you today. Take it away.
So you've all seen the disclaimer. Everything we're going to talk about today during the session is going to be current. You know, we're architecting current solutions. We're not talking about the future here. But we have to put this up because in the Q&A we might get to some futures. So just bear that in mind. In terms of an agenda, I'm going to take you through design methodology, architectural principles, kind of how we then look at applying that to Horizon components, and I'll wrap up with some multi-site considerations before handing on to Frank. And Frank's going to take us through a reference architecture that looked like performance and measurement of Horizon apps. The first section I'm going to reference two other reference architectures that we did. This is the Horizon 7 Enterprise Reference Architecture and the Horizon 7 Multi-Site Reference Architecture. All three are available on our website on the Horizon page under Resources. And we're going to refresh these in the near future as well. So let's start with design methodology. Now I always like to start with the why. And a lot of people look at me and go, well, I know why, right? Because my boss told me to. He told me to go and make 1,000 desktops. Right? Well, I like to think of it, in terms of, imagine we weren't in IT. Imagine the boss came to us and said, give the 1,000 people some form of transport. I know exactly what to do with them. I'm going to build 1,000 bicycles, right? So I go out and I architect a factory capable of building bicycles with 2 wheels and handlebars, and I make that and I hand it over to the users, and the users look at it and go, yeah, I'm not going to use this, right? We've missed the why. We don't understand why we're doing it. So always start with that. So what is the why? What's the business hoping to achieve out of this? If you don't understand the business objective, you'll never be successful. Right? So list out the business requirements, what the objectives are. Is it a differentiator? Is it enabling the workforce to do something different? Or is it solving some business issue problem? Next thing you need to understand is the how. Once you understand why you're doing it, what the requirements of doing that and solving that, work out how you're going to solve that problem. And then we can get to the nuts and the bolts, right? The what. What is going to fulfill my how, right? I now know I'm not building bicycles, right? I'm building cars because that's what the customer needs. That's what my users need. That's what my business needs to fulfill the requirements. So the what becomes building cars, but I need to build a factory to build those cars. I need to make that in a modular way to architect and design any type of car because the use case might change, the requirements might change. Now, once you've got your factory, you can actually build the physical car itself. We've got the ability to make chassis and engines and wheels, and now we need to integrate them together to create a solution, a service that we're going to hand over to our end user, our consumer. Just as we're going to construct a desktop environment, or a published app environment, or a workspace, or all three, as an end service that my end user, my use case is going to consume. And the last step in the circle, let's just validate it. Let's make sure we met the requirements. Did we fulfill the business need? Did we meet the requirements that all the use cases and the users needed? And if not, let's go back around the circle, tweak it, change it, and get to a solution that actually works. And most often than not, this is not around the circle once. This is going back around and tuning and tweaking and changing stuff, right? Especially if you treat this with a pilot or proof of concept. Go around this with a pilot, get some stuff wrong, then go back around and get it right. So how does this translate to Horizon? First step, and this is kind of common across lots of architecture, validate the business drivers, identify your use cases, categorize users by working patterns, understand how you can group them together and have commonalities, then understand the requirements that you need to fulfill to meet those use cases. Then the how, define the solution, define what I like to call the service I'm going to deliver. And I'll go into that in a little bit of detail. And then the what. So we're building a horizon environment. So we need to understand the architectural principles. How do I build this factory that's going to produce this? What are the rules I need to follow? How do I do it in a modular fashion that is scalable and adaptable? So within each of the components, I then need to design them out. The other bits we need to think of, right? Horizon relies on stuff like vSphere. It also relies on other things in your environment. So we need to think of all those things. But again, it's a modular design process that's building up to this capability of delivering. And our delivery is, well, let's bring this back and create a deliverable service, I said. And I'll go into this in a bit more detail as we go along. And the last one is for validation. Your biggest validation, not the only one, is going to be your user experience. Right? Do your users like this? Does it fulfill their requirements? And do they enjoy using it? Because generally with the end users, if it's not a great experience for them, they'll stop using it and work out some other way of using it. And then you've failed. Take that feedback, take it back around the cycle, and tweak. So the why. This is a sample. This is the kind of business drivers we sometimes talk about. Understand what your business is hoping to achieve here. Is it a digital workspace transformation? If so, what are they hoping to achieve out of it? You need to drill down to the business objectives and the value here. Is it differentiating your business here? Or is it coping with differing devices, making users more mobile because it's going to improve working practices? Understand that. Then start to drive out your use cases. As I said, this is categorization of working patterns. People that are maybe mobile or need the same set of resources, or maybe they all work in the same way. Try and collapse them down. Try not to have too many use cases. You want commonality here. For each use case then, start identifying the requirements. You can go, well, how do I identify the requirements? There's no substitute for talking to users. Interview them, talk to them in each of the use cases, understand the requirements to get the job done. Don't make any assumptions. And what kind of requirements? It could be understanding what applications they use, the working patterns. Do they work at a fixed location or are they mobile? Do they need specialized devices? Maybe it's a shop environment and they have tills with printers. Understand that pattern. Understand the requirements. And understand what the shortcomings of the current environment are so you can enhance and improve on it. Then we get to the how. We understand why we're doing it. How are we going to solve it? So for each of the use cases, let's start defining at a very high level the solution. Now, what I mean by the solution here is the end service, what we're going to deliver. So I know for this particular use case, I might be delivering a virtual workspace that consists of a desktop with some applications. And I'm going to put a bit of knowledge in here because the applications are best delivered through something like app volumes. We're not going to need certain components. One of the ways I think of this is drawing a high-level picture of the end goal without understanding how I'm going to get there at this point. So imagine you're running a restaurant and you've identified a use case of, this use case wants spaghetti bolognese. I can draw a picture of spaghetti bolognese. I know it's got pasta in it, and it's got mince, and it's got sauce and stuff like that. I have no idea how to make spaghetti bolognese. I'm a terrible cook. Right? I also have no idea how to make the factory, the kitchen, that's going to be required to do that, or the restaurant to serve the meal. But I could draw a picture of it and understand the components I need. So let's draw that out and understand what the requirements are there. Once we've got that, we can then draw pictures like this, blueprints of the end service. So from the user on the left-hand side here, they're consuming some service. The service they're going to consume is, to them, it's a Windows environment, an instant clone. That's kind of irrelevant to them. I know that's the best delivery mechanism for it. No idea how to make an instant clone at this point. No idea what infrastructure I need to support that. But we draw out the components that I know are needed to deliver the requirements of this use case. And you're going to paint a picture like this, one per use case. And then we can move on, and we can start designing the infrastructure, designing my car factory. So first thing we need to understand is, well, for Horizon, what are the architectural rules? We've had this for quite a while. We've had block and pod architecture. The whole concept here is to make stuff into repeatable blocks that are then scalable. So if I'm designing for 1,000 users, I design it in a particular way. If I design for 10,000 users, I just add more blocks. I scale up. So at a block level that I've drawn here, we have one or more vSphere clusters that are going to run our workloads, and we have a virtual center in front of it, and that roughly hosts about 2,000 users. If I need another 2,000 users, I build another block. Repeatable, predictable. Now, in front of those blocks are connection servers. That's the Horizon connection servers. They're common across all those blocks there. And we can add more blocks up until 10,000 sessions across all of them. And we draw a line around this, and we call this a pod. So a view pod of 10,000 sessions, made up of multiple blocks of each 2,000 each. We have common connection servers, as I said, across in front of them. As a user, I can hit any one of those connection servers, and I'll get passed through to my desktop. Doesn't matter which block it's in. But it then means I'm predictable and scalable, and I can build it out. If I need more than 10,000, we build another pod. And we join them together with Cloud Pod architecture. If we have 2 sites, 3 sites, we build individual pods in each site, and we join them together with Cloud Pod architecture. But we still follow the block and pod. Predictable. So once we understand those rules, then we can start building the individual components. So we understand the use case requirements. We've drawn our picture, the components that are needed to deliver that requirements. So I now know I need connection servers. I might need at volumes. Maybe I don't need true SSO. So I know which components I need to focus on. For each of them in turn, go through and design out how you're going to fulfill that. You understand the scale, the number of users in each use case. You understand the components required. Follow the design rules for each of them. So for connection servers, each connection server can handle roughly 2,000 sessions. I obviously need an N+1. I want redundancy, maybe N+2 if I'm really concerned about redundancy. So design out that and size it out. Follow the availability, follow the scaling rules. For some of the components, I might need database. So how do I provide database for that application, that component? How do I make sure that database is highly available? Again, you're treating each component within Horizon separately and designing out the scalability, availability, etc. of each of those. Some of them you'll obviously need to understand the impact. So true SSO might have an impact on the number of connection servers and impact there. But in general, you can design each in isolation to build up a complete solution. And I mentioned earlier, the physical environment is equally important. We've seen lots of people build very highly available, very redundant Horizon environments, lots of connection servers, load balancers in front of it, no single point of failure. And then they forget about the physical world, the rest of their environment. So the RDSH licensing server is a single service running on one server somewhere. And guess what? If it's not available, then none of my RDSH servers get licensed, none of my users get my applications. So you need to think about all those other supporting infrastructures, making sure they're redundant. Think about things like DNS, really important in a desktop environment. And even more important is DHCP. All our instant clones, all our link clones are going to be DHCP enabled. If DHCP isn't there, then the desktop's not going to work. You've got to think about lease periods as well. So DHCP has traditionally a longer lease period, which is fine for a server environment or static desktop environment. In a virtual desktop environment where we're deleting linked clones or instant clones very often, usually every day, your lease period should be 2 to 4 hours. You're going to shorten it down. And once we've got all that how in place, we've got our factory that's capable of building stuff now. I can now spin up desktops, I can create app stacks and app volumes, all the bits in there. I can bring it back and integrate it. I can create the end deliverable service to my users. We go back to the blueprint, and we go, what did I think I needed here? My spaghetti bolognese picture, what did I need here? List them out, and in turn just go through and create the components and bring them together into one service. So I need a desktop with an instant clone. So I'm going to have to create an instant clone master and then create a pool from it, unless I've got a master there already. If there are particular applications that are going into app volumes, then I need to create those app stacks. Create the group policies that are unique to this use case. Bring them together in a service and deliver it. And then, as I said, make sure you validate that, make sure you measure the user experience. So you build it up. In this particular service, we're going to have a workspace because one of the requirements might have been SaaS applications. So we want to unify that in. So we need to make sure they're entitled to the identity manager, and we bring in their SaaS applications and title in there. In terms of the core service, as I said, we're going to do instant clones. You need to create that master and spin it up. The applications, again, as a sample, you might be bringing in app stacks with static core applications, departmental applications that are unique to this use case. And maybe you're doing user-installed apps with writable volumes. And you might be doing thin apps and other things like that. Again, we're trying to show you all the options here so you can treat this in a modular fashion. And lastly, profile data. So don't think of profile data as one big block of data. With User Environment Manager, we're breaking it up, we're treating it differently. You're always going to have stuff like a mandatory profile. We always recommend using folder redirection. And then User Environment Manager will help you control the configuration of the environment and the applications. But you see, we're just layering these up and we're building up an end service. Okay, I'm going to change tact a little bit and we'll talk about multi-site design. When we talk about multi-site, you often hear us talk about active, 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 passive. Be very careful, we're talking about this from the user's perspective. In this example, active, active is a roaming user. I'm not talking about the data centers being active, active, even though they can be. Right? The user here is active, active because he could go to data center 1, site 1, and get his service, or he could go to site 2 and get his service. Fully functioning, fully active. We don't care where he gets service from. That's an active, active. To me, this is the rarer use case. The requirement for this is quite narrow. There's actually quite an onerous overhead in the user data. Getting that user data from site 1 to site 2 is usually the issue. We can supply a desktop, but if the user's data isn't there, how useful is it? But you can achieve it. What's more likely is this. The user is active passive. With cloud pod architecture, we're going to pin them to site 1, and that's where he goes unless there's an issue. Right? So his home site is site 1, and if site 1's compromised or down or there's some issue there, then he can go and get his service from site 2. There can be some manual failover required depending on what's in the service. And I'll go through some of these. What is not supported is stretching a view pod and connection servers that all talk to each other across multiple physical locations. So I cannot take my view pod, stretch it across site 1 and site 2 and put connection servers on both sites. Right? That breaks. You'll get bad things happen. One thing we can do is this though. We can use stretch storage, something like vSAN stretch cluster, across site 1 and site 2. The key here is we're going to take all the connection servers and we're going to pin them to one physical site. And if site 1 goes down, they all move, all my connection servers all move to site 2. I can never have a situation of some in each site. It has to be in one site. But we're using vSphere clustering to control that. So absolutely possible. So I mentioned kind of using Workspace ONE and Identity Manager. You know, if I'm doing on-premise, how do I architect Identity Manager for multiple locations? So within each site, we need a minimum of 3 Identity Manager nodes. We need that for the Elasticsearch. Right? So 3 working in a replica together, and that gives me scalability and availability. In my second site, I also need another 3 because I might have lost site 1. So in total, I need 3 in each site, 6. Identity Manager really stores all the configuration, all the entitlements, what's happening inside SQL. So SQL is the key here to making this also highly available. So we're going to use SQL Always On between site 1 and site 2, a SQL Always On listener. And that will automatically fail over if site 1's SQL server becomes unavailable. To further enhance it, you can optionally put in Windows clustering, local to site 1, local to site 2. That just means I don't have an OS failure. You know, it means that I don't have to fail over SQL into site 2. You can build up this availability. And one of the key things here is the 3 identity managers in site 2 are not active normally. You notice there's a dotted line there. The traffic is not normally going to them until there's a failure in site 1. And it's a manual failover at my global load balancer to say, start using the ones in site 2. So, app volumes. For multi-site, we can do quite a lot. Important to separate your uses of app volumes. So we've got app stacks, which are my applications that are read-only to users. And then we have writable volumes. With app stacks, we can make them absolutely multi-site available very, very easily. We can use app stack replication. We've got storage groups built into app volumes. So I can tag 2 different data stores or more, and it will just tell vSphere and to copy any app stack from one data store to another. So the example I've got here, in site 1, I've got storage group 1, made up of data store 1 and 2. Any app stack I put in data store 1 is automatically going to go onto data store 2. If I extend that data store onto data store 3, any app stack is now on data store 3. And if I do the same from site 2's perspective, I've now got a common data store sitting in the middle. So any app stack that lands on it will automatically get replicated out to site 2. So I've now got the app stack. Now I need to worry about entitling users on both sides. So there's 2 architectures, just a click. There's 2 architectures we can do here. And it's important to understand from app volumes, it's a stateless web service. All the configuration, all the entitlement is held in the SQL database. So really when we talk about an app volumes instance, it's the database that defines that instance. So the most common model, the one we generally recommend, is to keep them separate from each site. So a separate database and a separate app volumes instance per site. So there's no replication of that entitlement data from site to site, but remember we're replicating the app stacks themselves. So what we do need to do, if I entitle you to an app stack in site 1, I'm going to have to go and reproduce that in site 2. The 2 ways you can minimize this: use Active Directory groups for your entitlements. It reduces the touch points. There's also an automated way with scripting to take the entitlements from site 1 and reproduce them onto site 2 or site 3, etc. This keeps it separate, reduces your domain failure. Second option, let's have one instance that spans both sites. So I'm going to use SQL Always On listeners and clusters. And again, any entitlement I do on site 1, because it's in a common database now, is going to be available in site 2. But we're still using the same app stack replication trick. Writable volumes, they're slightly trickier, right? These are virtual disks that we don't really know what users are writing into them. We also don't know the consistency, the state of the data in there. But we need to choose points in time to replicate them. So how do I replicate that virtual disk from site 1 to site 2? Well, there's lots of ways we can copy it there. We can back up, restore. There's a fling that allows you to back them up and restore them and stuff like that. The key is getting them there and understanding what state they're in. If your users are continually writing into them, have I now corrupted their data? Right. So use writable volumes sparingly, reduce the problem, but there are ways of replicating them out. And then you end up with a service like this. So we can have a user who's active in site 1. That's their active site. They passive into site 2. I could have them active apart from the writable volume. Right? Because again, app stacks, I could entitle to you on both sites and we're confident they're writing. Right? The writable volume is the sticky bit. So we've got customers who have said, in a DR scenario, I don't care about the writable volumes. I'm prepared to lose them. So I don't back them up. Right? That's a choice you need to make, whether you care about it enough to do disaster recovery and multi-site for it. The last thing I want to cover in multi-site is user environment manager data. There are two types of data here. There's the IT configuration, and then there's the user personalization. The IT configuration is read-only to the user. So we can support DFSN, so a common namespace, and use DFSR to replicate that. If you want to use a different replication technology with multiple entry points, absolutely supported, absolutely fine. They're just files. If you want to replicate them and have them available in multiple locations, that's perfect. It's read-only to the users. The key discipline I'd say is for IT to only change it in one place. Again, to make sure there's no conflicts. So if you've got two administrators changing it, one in this file share and one in that file share, and they happen to change the same thing, then you've probably got the last version saved and confusion. So discipline is change it in one place. We don't care about having multiple entry points. Where it becomes tricky is when we get to the user personalization share. There's a couple of rules we need to follow here. This is profile data, Windows profile data. So there's rules that Microsoft have put out. They have support statements and blogs on this, and they're quite strict about this. Right? Profile data is easily corrupted. Right? We can easily get conflicts. With DFSR and DFSN, there's really no conflict resolution. Again, I can change data in two sites and corrupt it. Have two writes, and then I've got the last copy written in. So the answer here is we can have use DFSR to replicate this or any other replication technology, we don't care. But we only have a single entry point active. So we can do DFSN with a single entry point into a single server. We can have disabled entry points on other ones, and in a disaster, we go and enable them. But we can only ever have one active one to comply with the Microsoft statements. So you end up with this. We can have the IT configuration active in my site 1 and site 2, but my user personalization, my user profile, it has to be active only from one site. The entry point is in site 1 here. You're probably also going to have to do the same for the user data where you're doing folder redirection. It should only be active one site. And this is where it leads to most use cases being active-passive. You can see we can provide the desktops, we can do the app stacks, get the applications in there. What's harder in practice is getting the user data. Even like their Word documents, Excel documents, how do I replicate them so if I log off from site 1 and 2 seconds later, I log back in and I get redirected to site 2, how do I get all those documents here in a timely manner to not confuse my users? So hopefully that gives you an idea in terms of multi-site, how we can break down some of the challenges. And with that, I'm going to hand over to Frank, who's going to take us through some performance figures. Okay. Thank you, Frank.
Thanks. So Graham provided a lot of great methodology and some guidelines for deploying Horizon 7. But let's see what that looks like when we put that to practice inside of a reference architecture that has scalability and performance in mind with that. So I'd say about 2 months ago, we released a Horizon 7 apps RA, which is based on RDS-H as a deployment model. And with this, there's two different types of reference architectures. There's some that are more functional in nature, and there's others that are performance geared, and which is this one. So where we are validating a certain amount of bill of material equipment that's in there, against a specific amount of users in there, and to determine what the performance characterization is, and also, of course, to provide a validation of interoperability and functionality, and then, of course, scalability and performance, too. So that's what that does. Part of this architecture, and a key aspect of this architecture, is that it provides validation for the Enterprise Edition and the Apps Advanced Edition of Horizon 7. So that includes the jump components in there. So that's going to get you a validation and performance testing for instant clones, user environment manager, and then in app volumes. So this is the first of its kind in that way, that we're actually battle testing all of these different components and putting that in there. And we're also putting in top of vSAN as well. So you're getting a vSAN configuration with that full stack approach for a performance study. That's something that's very important. All right, so for the building materials, referring back to what Graham had said before, we are breaking out the management block from the resource block. So we used 4 workload hosts as part of that resource block to host the RDSH virtual machine environment, and that's, once again, that was built on top of vSAN. So that's using the E5 2698, a little bit higher end processors, and those are the Broadwell V4s. That was 384 gigs of memory in there with 5 800 gig SSDs, a single drive set for a single data store for virtual or vSAN for the RDSH systems. And then we use 2 infrastructure hosts to do the management block there. So that's the 2 hosts that's going to go ahead and accommodate for the Active Directory systems and connection servers, app volume managers, all the infrastructure things to make a complete solution to do that. So those are a little bit, so those are V3 products, a little bit lower bin processors, and you'll see the utilization on that is significantly less than that of the resource host. So Cisco Nexus 9372 switches were used for the core network as well as the storage connectivity. And we also used some fabric extenders for the compute layer to do that. We had a Tagile T3600 to use. As I said, we used vSAN for just the RDSH VMs, but we used an array separately for the app volumes data store, as well as the CIFS traffic for the user data tier, as well as UEM data as well. And then finally in this login VSI we had is a separate cluster, a separate block, and so separate equipment to do that, so it wouldn't skew the environment. It was completely isolated in that way. Software components, so we used Horizon 7.1. This was what was current at the time doing the project. Of course, there's 7.2, a point release newer. It does not impact the numbers and scalability information that I provide to you is relevant and valid for the latest version of the product. So it's really not anything different from a performance standpoint. And then we used Horizon Client 4.4. Same applies there. vSphere 6.5 was used with the Virtual Center Server Appliances, or VCSA, dedicated ones per block, of course. And then, as I mentioned, vSAN. App volumes and UEM were in the mix, and we used Windows Server 2012 R2 for anything that was Windows-based in there. So the app volumes managers, the connection servers on the infra side, and then on the RDSH side as well to run that, so that was consistent. Microsoft Office 2016 Pro Plus 32-bit was used for some of the core applications in the workload. And the latest version of Login VSI was used as well. And I'll go into a bit more detail on that. So this is the overview of the environment. So we got the different clusters. We'll go right to left with this, looking at the infrastructure cluster, which is, once again, where all of the core components, like the connection servers and app volume managers, that's where that resided. We have the RDSH cluster, which has the 4 compute nodes in there as part of the vSAN cluster. That was 32 RDSH VMs that comprised that, to be able to serve up a workload of 700 users, as I'll go through some of that data in a bit. And then finally, all the way to the left there is the VSI cluster for where you accommodate for the clients and the launchers, as well as the VSI share and repositories where it logs out to. Okay, so this right here shows the workload distribution for the resource and the infrastructure virtual machines right there. So key slide, it shows we start off and talk about the RDSH cluster once again, 4 compute nodes, and those were 8 RDSH VMs per host node. So that's going to give you around 22 user sessions to run per RDSH VM, which brings you to 175 sessions per server at that point. This accommodates for N+1 added to the mix at the compute layer. So you're getting N+1 added for high availability both for RDSH as well as the infrastructure VMs. In this case, because that's where the number is, and we only have 4 compute nodes in there, it brought that number to 175. Really a key point I'm going to do, this was not about speed and feeds, this RA. This is about having a resilient, reliable, highly available solution. So we're not after trying to get the best user density out of this and that. Having said that, we did optimize the solution. We did use the OS optimization tool, follow the best practices, also make sure that we got the vCPU to core ratio correct and optimized for that environment. So that 22 user sessions per RDS VM to get you to 175. So that's with the a collection of 4 servers and 32 RDS VMs to get you 700 users. You can afford to lose one of them. So in the event that you do lose one, you can go down to 3 host servers with 24 RDSH VMs and maintain that same user load. Those RDS VMs are running about half capacity there, in that one, just to be able to have that capacity to be able to support a failure. Also, DRS and HA with disabled for that resource cluster is also a best practice. There, you want to make sure you got the right amount of vCPU configurations in VM, so you have those fixed or parked to host servers. So you build that level of redundancy and resiliency in at the VM and at the host level. So the 2 infrastructure hosts, you can see all of the infrastructure VMs are paired up to 2 connection servers, 2 app volumes managers, so on and so forth there. So that one, HA is definitely enabled. If you lose one of the servers, it fails over. If you lose one of the connection servers, it can maintain. I have VM level stats, lots of details into that RA to be able to show what those performance characteristics are throughout the testing. Next up is app volumes, the app stacks, and configuration. So here we used 2 as part of a general test bed to do the validation. 2 app stacks were used, one for Microsoft Office 2016, the other for the remaining applications that are required by Login VSI, which is Adobe Reader, Flash, Java, and then you have that the PDF print app as well. So I put those up. There's a lot of ways you could do it. Is this real world as much? I would suspect that most of you guys are going to put Office or bake Office in a base image and probably not have it as an app stack. And then you're going to have a multitude of different app stacks, different conditions with that. I completely understand it. This is for the purposes of benchmarking. So you can have a repeatable process for doing it and be able to see what the results are with it. So that's what the logic is. Once again, the data store for that was located on the shared array, in the shared storage array, and it was a dedicated single data store with that. So, all right, next up is the Login VSI test tool was used, and this just kind of gives you just an overview of what workload was used. So they have an option in there referred to as benchmark mode, and you put this in benchmark mode. It has a fixed set of parameters that you can't go in and change the total test duration, a lot of these type of things. The reason for that is so that you can have a standardized method and to be able to do testing where it's consistent, repeatable, and you can't game it. You can't make a 2-hour-long test run to be able to maybe artificially or skew the results in some sort of a way where you can get better application response times or there's so on and so forth. Also, when you put it in benchmark mode, you have the 4 different workloads, but when you put it in benchmark mode, you only get the office worker and the knowledge worker. The knowledge worker is the more aggressive of the two in there. So once again, wanted to battle test that solution out to make sure that it was performing at its peak. So this is the test results as what VSI reports. So login VSI provides a lot of data for their login VSI max. The max chart is really one of the key points that you're doing with this. So login VSI, for those that are not familiar with it, it provides 2 great things with this. It gives you the workload, a synthetic user workload to be able to test against. And it simulates user operations such as opening up applications, typing an email, printing. It plays a video, server-side rendered video as well. So it does a lot of these user-simulated operations to mimic an office or, in this case, a knowledge worker. So it reports that information back, as you can see in the vertical axis there, and the response time in milliseconds. So it has that, and then if you look in horizontal axis, so under active sessions, from 0 up to 700, that's the amount of logons that occurred in there, so a ramp up. So that was 700 user sessions, once again, it was tested, over a 48-minute duration, which brings you up to about 4 seconds, a login every 4 seconds is what that does. So that represents the end user experience. How quickly user can do operations and the application response times is a direct reflection on how well the user experience is coming across. And you can see the scores there towards the left. We got a baseline score of 730 milliseconds, which is really good. Anything under 800 is stellar results. So that's what we got here, and that's something that's computed towards the front end of the test. And then they use that measure to establish a threshold. You can see that red line across on the chart. And then along the way, you reach what they refer to as the VSI max. So that's when it's considered to be, you reached a saturation point or the high water mark for the solution when you get to that. Well, we never tested that point. And if you have your environment correctly configured, host CPU should always be the gating factor. So we want that to be way down, and you'll see some of the other results of that as we go along. Another important part, not everybody does this. This is VMware internally, we established a success criteria and a methodology used for testing. You can go out and you can do a one-off test and get a certain result with it, but you want repeatability, so you really need to do consecutive user testing or consecutive environment testing and be able to determine that. So written into the specifications, it's in the document what that success criteria is, but we want to have 2 consecutive test runs and make sure you have less than a 1% variability between those 2. I've been doing these reference architectures for EUC a long time now, for many years, and done a lot of solutions. There's a reason why they call it a validation. It doesn't always work out. Sometimes you've had results where when you're trying to do that, you have this skewed results or varied results between these test runs. It's times where some of the solutions I've worked on never saw the light of day. Maybe they had hardware problems, or we spent the next week or 2 having to dig really deep into a configuration change. One time I had a CNA on a storage controller that had problems. So that's why you do a validation. You want to be able to search that out if there's any issues with the problem in the environment. Things at low scale you don't necessarily always see. It's not till you scale that environment up and you apply load to it, and then you repeat that load to be able to determine repeatability and resilience in the environment. Next up is the host performance. So I'm going to give you a snippet there. They got lots of detailed data. I can give you some cursory information, and definitely as a call to action, I encourage you to go and read the paper for all the details of it. So for RDSH, the ESX host servers, once again, that was 4 servers, 32 RDSH VMs with vSAN. So this is what the charts looks like there, and the metrics that are in there. This is based on ESX top. This is the host CPU utilization once again. So we have, what I did here is I put all 4 servers together on each of the charts, all the data points for the servers. The reason why I did that was deliberate, is to be able to show you how well the workload was balanced and the consistency across the workload and across the host servers, to be able to show you how rock solid that configuration solution really is. So, and also if you look at the callouts, I don't know how easy that is to see, but you'll notice that I put callouts for each area of the test phases. So you have the boot, where I do basically like a boot storm, right? Where I boot up all 32 RDS VMs in less than a minute. And then you do basically like just a quick 15-minute cool down, then do what they refer to as a login phase or ramp up phase over that 48-minute duration. They get all 700 user sessions in there. You go to steady state, and then where you're running at peak load, and then you log off the sessions to get a complete life cycle view of what that performance, the performance test is about. So cold booting all 32 RDSH VMs, you see it get a spike around 30%. Not too bad. This was VDI, and you're trying to run 175 user sessions. You guys know that would be a little bit more aggressive, right, for that one. But for RDS, 32, not bad. Next up, steady state, so 65% average CPU utilization doing steady state. So, at full mass, that's not bad at all. And the reason why I kept it at that amount, once again, is to be able to accommodate for the loss of a server. In the event that you lose one of the 4 servers, that's going to go up to, and I did, of course, test this, so it goes up from 65% up to between 90 and 95%. You reach 100%, of course, you just impacted the environment and will cause poor user experience for everybody on that host server. So you can, once again, afford to lose a server, maintain that load as well. The memory, I had 384 gigs of memory in this environment. As a general rule of thumb, you should do like 1 gig of memory per user session for office or knowledge workers. This is just a general rule of thumb. Your mileage will always vary. This brings us to 150 gigabytes of memory doing steady state. So pretty good amount. If you compare that, that's about half the amount of memory needed for VDI, or even a little less than half. You could get by certainly doing 256 gigabytes of memory, maybe even 192, depending on what your workload is. And that was also using where I reserved all guest memory, 32 gigs of memory per RDSH VM for that. That was VDI running the same workload. You probably go with 2 gigs of memory for the Win10 VMs, and that would bring you up to, you need 512 gigs of memory to support that workload in that. Okay, for the network utilization, and by the way, that memory usage was non-kernel memory as well, so that doesn't count for the overhead of the hypervisor and vSAN, those things too, which is going to add about, well, anyway, it's going to add a little bit more to it, not an incredible amount. Network. So this is, I used 2 10 gig E ports that were available in the servers. So this is the VMNIC 0 and VMNIC 1 stats. So it's the aggregated sum of all the network traffic that was occurring there for vSAN management, the VM network. Of course, it's a best practice. That was all separated out through VLANs. But this is, I wanted to show you what it looked like at the physical NIC level. So doing boot, you got around 2 gigabits per sec, that brief spike. But doing steady state, you're looking at a half a gig, so not bad there, very acceptable. For the infrastructure ESX host, that is a lot less. So once again, comparably so, it's around 15% at peak to run those per server. So not bad there. We have them separated as a best practice. There's some situations. I even did an RA. I built an RA or designed one a couple of years ago where I did like a robo scenario where you commingled together the user workloads and then the infrastructure VMs all together for branch office scenario. That's totally okay. Or you can also use other infrastructure related services outside of EUC and commingle that on that front too. The RDSH virtual machine. So this is a representation of the 32 RDSH VMs. This is at the guest level. So once again, I was telling you about the capacity of that. So I'm showing you here that for the peak CPU usage was around 50% or so, a little less than 50%, with 22 user sessions per VM. Well, if you go from 4 nodes with 32 gigs of memory down to 3 nodes with 32 VMs down to 24 VMs with 3 host servers, and that CPU usage will go up, but it's still great. That's 8 VMs with 8 vCPUs, and that directly maps to, not directly, but it gives you to 64 CPU over a logical CPU core allocation. You got 80 to work with those servers, so there's a 20 core procs there, and it works out really well. So that's with, if you look at some of the other things, well, let's just, I see I'm getting a little closer in time here. So lots of details in that RA, so I definitely recommend going in if you wanted to see the nuts and bolts and exactly what's happening at the VM host level, etc. So next up is the infrastructure virtual machines. This is the key point here, once again, around high availability. If you look at the CPU usage of each one of those VMs that I have there, it's all less than 50%. Once again, you can afford to lose one of those and still maintain your full 700 user load with no problem. Okay, for the virtual SAN or vSAN storage performance, as I said before, this is just the RDSH, only the RDSH VMs themselves were hosted inside that cluster. So that's so if you look at it, the latency was around sub 5 milliseconds. A lot of the AFAs or the all-flash arrays that you're talking about, it's like sub 1 millisecond to latency. When you talk about hyperconverged infrastructure, this is the gold standard right here. So getting below 5 milliseconds doing peak works really well. The fact that I used SSDs in this helped that incredibly too. The rest of it was the default storage policies that are in there when you add both vSAN and Horizon into the mix. So you have like FTTT1, so there's a 2 copy in there. Everything else is the same from a caching. Those are all defaults. You're getting really great results. If you look at the throughput too, where you talk about the read and write ratios, as a general rule of thumb, it's an 80 to 20% or an 80-20 ratio, and with that, it's well represented here, and you can see that too. The IOPS are pretty low too. You peaked doing boot up to 4,000 briefly, just for boot, and then the rest of it really leveled out. It's not that much. And the reason why is because I used home directories too, VSI. So if you do that, the real truth is the heavy lift for around storage for in-user computing is not really the operating aspect of the virtual desktops and the RTS systems as well. It's not that at that level. It's actually the use of data. You separate that out, and that's where it is. So I've actually done a 5,000 seat study where it was 65,000 IOPS. 55,000 of it, this was an all-flash solution, just 55,000 of it was all CIFS, user profiles, home directory data, and all. And lastly, I'll run through this, is the app volumes, app stacks performance itself. Pretty light. There's 2 ways that you can entitle app stacks. You could do it at the machine level or user level for entitlements. Because this is RDSH and we're doing shared sessions, within a VM, we attach it at the OU level to the machine account. So with that, it's at boot time, as opposed to log-on time with it too. So once again, really low latency as observed. And if you look at it, doing even the boot when it was attaching the app stacks to each one of the VMs, it was 7 kilobytes per sec. megabytes, sorry, because it's 7,000. So 7 megabytes per sec. And the IOPS too, pretty low, 350 for boot, and a little less than 10 for the overall running of it. So for all 700 user sessions, that's not bad at all. So in conclusion, the solution is made to be, once again, battle tested, validates the functional and interoperability and performance of the solution, reduce the amount of risk associated with doing the implementation, the operational risk associated with it, and then lastly, it really shortens the time it takes to do implementations, and that's the true value of a solution like this. So with that, I'll turn it back over to Graham to wrap us up.
Okay, thank you, Frank. 3 reference architectures I mentioned at the beginning. Frank took you through the Horizon 7 apps one. The 2 I took a lot of content from are the Horizon 7 Enterprise one. Go up and find that one. It teaches you how to architect Horizon. It goes into a lot more detail than I was able to cover today, so we don't have a lot of time for it. But also the multi-site one will go through how you architect the different components for multi-site. Do please complete the survey. And with that, we've got a couple of minutes left in the clock down here. My watch says something different, but I'm happy to take a few questions. And if we run out of time, we can take questions in the corridor as well.
Thanks, guys.
Thank you.